Hello, good morning, good afternoon. Welcome to Automation Use Cases, sponsored by Word Solutions. My name is Chris Reese, and I will be hosting our time together today. I'd like to welcome all of you to this webinar. Thank you for taking time out of your day to discuss what I think is a really important topic. As I said, my name is Chris Reese. I'm technologist at Word Solutions. Let me take care of a couple of housekeeping things before we get started. First, if you do have questions, and I hope that you do, please open the chat panel and send me a chat with whatever your question is, and I will do my best to respond to those questions as we go through the presentation, or if you have questions at the end of the presentation. We are recording this webinar, and you will receive an email of how to listen to a replay of this webinar, as well as you will receive a copy of the presentation that I'm showing today. That will come in the next few days. Give us a few days to get that to you. As I said, this is sponsored by Word Solutions. Word Solutions is a proven leader in technology training. We've been in the industry for 23 years. Our focus includes things like 5G, 4G, as well as the stuff that I'm more interested in, which is artificial intelligence, machine learning, automation, data visualization, Python, Ansible, and data insights. As a special thank you to all of you who are attending this webinar, I'd like to extend to you a little offer that's valid through September, which is if you'd like to take a data automation workshop with Python, which is a 5 half-day course, you can sign up and get 50% off the price of that course using the coupon code automation50. And after the course, after our webinar today, I should say, feel free to connect with me via LinkedIn if you don't get that code, and I'll be more than happy to send you the code and the link. Just reach out to me on LinkedIn. With that being said, what I'd like to do is I'd like to go ahead and get started with the content that we want to talk about. And I'd like to, again, thank everybody who is on this webinar. What we're going to talk about today is we're going to talk a little bit about automation in general. What are some of the automation use cases? And then we're going to look at 3 major areas of automation. We're going to look at robotic process automation. We're going to look at what I refer to as just Python-based automation. And then we'll look a little bit at Ansible. Now, there are other ways in which we can tackle automation, but these are the ones that we're going to look at today. But if you have questions about really any of the other aspects of automation, please feel free to jump on the chat and let me know. So we'll start with automation use cases in general. So whenever we talk about automation, the first question that I want to ask is, how do we improve productivity? Now, notice the way that I'm phrasing this. I'm phrasing this very specifically. In how do we improve productivity, not how do we eliminate work? How do we do things? We're trying to take the staff that we have, the people that we have, we're trying to take our own jobs and be more productive. And the example that I always like is 5G. In 5G, we're going to have at least 1, if not 2 orders of magnitude more cell sites. Are we going to grow our staff to manage those cell sites in that way? No, we're not. So what do? How do we handle supporting all of that additional work? Well, that's where automation needs to come into the picture. So what does that really mean? Well, what it means is we're going to take some repetitive tasks, some tasks that we do over and over and over again, and we're going to try to eliminate it. Here at Word Solutions, we do technology training, and we have labs. And the lady that's in charge of our labs, she was going through and manually looking at our schedule to try to see what courses were upcoming and setting up the labs appropriately. I came up with a Python code so that I could do that automatically for her, and I was able to save quite a bit of time that she spent on a regular basis. So why do we automate? Well, we're automating to lower costs. We're automating to increase agility. Because of that automation program I wrote for her, I caught things that she missed by accident. She was looking at the schedule manually and she missed a course. That'll hopefully increase our customer satisfaction and then increase our revenue. That's the goal. That's the goal. So here at Award Solutions, we have a concept that we've come up with called a define in 9, which is a technical term defined in 9 words or less. Now, obviously, if you're defining a definition in 9 words or less, it can't be exhaustive. So this is a good starting point for the conversation. So how do we look at automation? Well, it's tools to bring efficiency through zero-touch processes. I'm trying to accomplish something without manually going and accessing that tool, logging onto that web page, connecting to that server, downloading that spreadsheet, something that's happening automatically. So what are some examples in which we can do automation within the telecom space, within the service provider space? Well, I can automate configurations. I would like all of my servers, I would like all of my network to have as few different variations as possible. Variations are really difficult to troubleshoot. So I can use configuration to automate, or use automation to configure all of these different servers, all of these different systems. I can use automation to do remediation of problems. And so instead of having a human being manually look at things like trouble tickets, maybe I can do automation to automatically look for fingerprints in that trouble ticket and send it to the right person. Or as multiple systems that are related all provide alarms, maybe I can have automation have all those things come together so I'm not manually trying to correlate those alarms. Maybe I can do something like automate capacity adjustments. Maybe there's a way I can automatically add more resources to one specific aspect of my network. So what does automation need? Well, we need skills. We need the ability to actually think through what the process is and try to figure out what's rudimentary, what's the repetitive task so that we can automate it. We'll need tools. Now, some of those tools may be something very sophisticated. We'll look at robotic process automation, where we're really using that tool to do most of the work. Sometimes what we mean by a tool is some type of a programming language like Python, or some type of a scripting language like Ansible that's going to allow us to automate some task. And we need to have a good understanding of the business processes, and they need to have an appropriate level of complexity. If what you're trying to do is a simple logging onto your computer, automation is probably not going to do that much. If it's something that occurs once every 1,000 years, automation probably isn't going to buy me a whole lot. But if, on the other hand, it's something that you're spending an hour every day doing, or you're spending a couple hours a week doing, maybe it's something that we could automate and you'll get that time back. So what do we need to automate? Well, we need to understand what actions need to be taken. We need to understand the data that's needed for that action, and we need to have the appropriate insight to make that happen. And probably the two bigger pieces of this is we need to have the data, and we need to have the ability to turn that into some type of an insight so that we can use that. That's when we're going to automate. What do we automate? Any repetitive task. Any repetitive task. If my job is to look at incoming alarms and figure out how to put an incoming alarm into a specific bucket or into a specific trouble ticket or whatever, then that's a great example of something that might be a candidate for automation. Now, as we think through this, automation can't be a once and done thing. Automation will never be something that we just automate one day and then we've got all the automation fixed. automation is going to be a process. And so what we're looking for is we're looking for some of the low-hanging fruit. What is the things that you're spending the most amount of your time on? And if I can automate that, then I can move on to the next one, and the next one, and the next one. So here are some use cases. And what I did is, and this is kind of a simplistic list, but this is a set of use cases that were used in the course that I described a little bit earlier. And we do a subset of these use cases in that course. So it could be, for example, doing some type of an audit. So I'm opening up some type of a file and I'm doing some type of a basic audit on that. I could be getting data about a specific course. If I'm within the telecom network, maybe I'm getting router data. I'm connecting to a device and running some type of application. SQL data. Getting APIs or KPIs, getting KPIs from a specific, in this case, an eNode B, an LTE base station, and so on. But these are a very small and very simple list of potential use cases. And once you have some basic skills, more and more complicated use cases can come about. All right, excellent. So as we started this conversation, I said there's 3 different specific examples that I want to look at: robotic process automation, Python-based use cases, and Ansible-based use cases. We'll look at robotic process automation first and for the least amount of time. Robotic process automation is abbreviated RPA. And the problem that it's trying to solve is referred to as a chair swivel. So what I want you to imagine is I want you to imagine a scenario where you've got legacy systems within your network. This can be a telecom network, this can be in other areas. But you've got some type of a legacy system that you're dealing with. You have a subscriber that is having some type of a problem, and what you need to do is you need to look on one system, then turn to another system and type information in. That's the reason the term chair swivel is talked about, because envision, I've got one system over here and I'm physically turning to use another system over here. If there was a way to have those 2 systems talk to each other directly, that'd be great. But a lot of legacy systems don't support that. They don't support sophisticated interfaces like APIs. So we need to have something else. And that's where robotic process automation comes in. So what robotic process automation is doing is it's automation of repetitive tasks through scripting, as well as other techniques. And what our goal is to reduce or eliminate the need for humans to perform these tasks. And so what I want you to think about when you think about RPA is I want you to think about, and this is where the term robot process automation comes from, think about a software robot. And what that software robot is doing is it's emulating human tasks. And what I mean by emulating human tasks, it's things like clicking a link, entering things into a form, copying data, pasting it into a spreadsheet, and so on. Some examples that I've seen are things like just going to a specific website that doesn't have an API and searching for specific information. So, for example, in one of the tutorials I saw, they were going to Yahoo Finance and just getting today's stock value for a handful of stocks and writing it into a spreadsheet. Fairly simple. In your network, what are some of those legacy systems that you're trying to deal with? And how can you use something like this to minimize human intervention? That's where robotic process automation comes in. Now, unlike a lot of other automation techniques that we're going to look at, this is typically coming through some very specific tools. Now, this is a very short list, and there's more and more vendors of this type of tool coming all the time. but this is a good starting point if you're interested in more details on this topic. So typically what you do is you're installing a piece of software, Automation Anywhere, Work Fusion, Blue Prism, UiPath, and then you're doing scripting within that tool. And then that tool could open Internet Explorer or open Firefox. It can go to a specific web page. It can SSH to a specific thing and so on. The one that I have the most experience with is Work Fusion. And the reason is simply because they have a community edition, and it was easy for me to install the community edition and play with it, versus having to have a paid version of this. And there are some other tools that are coming about where you can integrate some of this within Python as well. So RPAs are a great tool depending on the nature of the problem that you're trying to solve. Here at Award Solutions, we have a tool that we do for all of our scheduling. And it's an older tool. We've had it for quite a while. And so I was using RPA to do some very basic things with that tool. That's kind of an example of how I might use that. Let me pause for a second. Questions, comments, thoughts? If you do, please feel free to jump into sending those in the chat. Okay. All right, awesome. And as I said, that was the one I wanted to spend the least amount of time on. I want to spend a little bit more on a couple of other examples. And the next one I'll talk about is Python. And Python is probably one of the most popular languages to do programming in today. And we'll take a look at some examples of that. So what is Python? Well, Python is a programming language that lets you quickly do some task, and it integrates systems very, very effectively. There is a Python software foundation that is dedicated to the advancement of Python. It was originally conceived in the 1980s. It really didn't get a lot of usage until kind of into the later 90s, early 2000s. And Guido van Rossum was the creator of this. And he was just looking for a hobby. He just decided to, he wanted to see if there was a way of providing some type of system that would allow him to do something a little bit more efficiently than what he did in C or C++ sorts of things. Now, where it gets its name, and I did not know this until not that long ago, and I'm fascinated by this, but where it gets its name is it comes from Monty Python's Flying Circus. And so he was a big fan of that, and so that's the reason he decided to name it Python. Even though people have kind of locked onto the Python name, and a lot of the variations or a lot of supporting things are like Anaconda and that kind of stuff, it really comes from more Monty Python. There are two versions of Python, and this is very important because there were some pretty big differences between them. And so typically what you'll see is something that supports Python 2.x, which was last updated in 2010. And then more recently, we've got the 3.x versions of Python. And it is been updated as recently as this year. Has improved usability, better consistency, and easier to use. And so what my experience has been, if you're trying to use Python, you want to use the latest version you can, but if you have a large install base, then you might stick with version 2.x. And there are some examples of that. Probably one of the bigger examples is, and I don't know if this is still true, but it was true about a year ago, is OpenStack. OpenStack was written in Python 2.x, so therefore, if you were doing any type of coding to support the OpenStack project, you had to use the older version of Python. This is a chart that comes from a survey that Stack Overflow does every year. And if you're not familiar with Stack Overflow is a website that is basically a forum to use to answer questions. If you're having some type of a struggle with some technical thing, you can go on to Stack Overflow, you can pose questions, people will post answers, you can search based off of previously posted answers. It's a very, very, very good website. Well, they do an annual survey of top programming languages. And what you see a screenshot of is the top roughly 10 most used languages as determined by the professional developers that use Stack Overflow. Right, so this is a survey that Stack Overflow provided to their the people who use Stack Overflow. And you'll see about 40% of all professional developers are using Python at this point. And that's a number that goes up year after year after year after year. And you can start to see things like C and C++ and C#. Those are starting to kind of move down the list. They're not as popular as they were before. We're starting to see things like PHP, which is used as part of web pages, backends. We're seeing things like Java. They're starting to move down as well. So Python is continuing to move up the chain. JavaScript is still extremely valuable. HTML, CSS is extremely valuable, as well as SQL. But Python is continuing to move up that list. And comparing 2018 to 2019, the order was about the same, but the percentages associated with Python were higher than they were in 2018. And that's one of the reasons why I like to look at Python. Another reason to look at Python, it is a very high level language. It is an interpreted language. So versus being a compiled language, you'll use some type of an integrated development learning environment, and you could write your Python code. The Python interpreter will run. It'll interface with the operating system, in this example, Windows, and then interface directly with the CPU and the hardware. Most integrated development and learning environments have a shell window as well as an editor. There are multiple types of editors that are available, and then also there's some type of an output window that you'll see. So how do I create a program? So I'll design my software, go through some type of an editor, and that will end up with some type of a text file. Maybe I'm going to have some type of a configuration file or configuration information that will go in. And then we'll actually go into the interpreter, which will turn that into machine execution commands that interface with the CPU, opens any internal files, links things together, and then executes on the CPU itself. And in the lower left-hand corner, what we see is a really simple example of a Python code using just Notepad++ as the editing tool. If we're running a program, we just type the name of the program. We might type something like Python space the name of the program. It will load all the appropriate pieces. It'll link any dynamic libraries, which we're going to talk about a little bit more in a second. If there's anything about Python that I think is really important, it's linking of these dynamic libraries, pulling whatever image into RAM, and then scheduling the appropriate processes and running on the CPU. Now, Python is a very straightforward language to use. Being a programmer from 30 years ago, when I was programming, it was I had to think about everything in a very small detail, right? If I wanted to add two variables or two arrays together, I had to go object by object. I had to do element by element to do that addition. Python does things quite differently, and it's a much more abstract. Another thing that they've added is a very rich library base. And it's very, very extensive. There's a lot of open source stuff as well as proprietary things. And they offer a large amount of functionality, a lot of modules. And these modules are what I think are very important. What these modules are going to allow us to do is they're going to allow us to very efficiently solve the problems that we're trying to solve. And I'll give you some examples of some of the modules here in a second. There are platform-specific APIs, or I'm sorry, platform-neutral APIs that allow us to do some very sophisticated things. There's also a very detailed Python package index if I need to install certain libraries onto my system. Some of the components of the library. Sorry, I got ahead of myself. Some of the components of the library it has specific libraries that deal with specific data types. There's a lot of built-in functions, but there is also a number of new functions that I can just import in. And really it goes back to a lot of those modules. Now those modules may be written in C and built into a Python interpreter, or it may be written in Python itself. Here is a very, very, very short list of standard libraries that we see within Python. Things like socket, threading, random. Random is one I've used just to generate random numbers. If I'm doing something with JSON, there's a JSON library that lets me manipulate JSON. I use that a lot for doing API calls. Sys helps me with runtime issues, and so as I'm trying to debug my code, I'll use the sys module quite a bit. Logging, CGI, date time, paths, select, math functions, CSV functions, XML functions, and so on. So a little bit on Python. Please do me a favor, jump into the chat. And the chat is set up to where I'm the only one that's going to see it. So you can share information. It won't be visible to everybody, but jump onto the chat. And just let me know, have you programmed in Python before? And if so, what are some of the use cases that you've thought about using Python for? For me, most of it is really in the realm of data manipulation. So I've got one person that has used that. That's fantastic. Let's see. LTE parameter updates, mostly for data manipulation. I see one person have. Game developing. Oh, that's interesting. Data analytics. I've got somebody who's never used Python, no problem. Neural networks, okay. One person has neural networks and TensorFlow. So one of the other things that Python has done a very good job of is there's a number of libraries that are good for artificial intelligence, machine learning. And TensorFlow is one of them. And it's a very, very good language so that you can focus more on the problem you're trying to solve than the coding that you need for that. So that is a very good example of this. One other one that's not on my list, I'll go ahead and just put this into the chat, is something called Pandas. And Pandas is a library that I like that allows me to do some very big data manipulation kind of all at once. So for example, what I'll do is I'll read a spreadsheet in, the entire spreadsheet, one workbook or one worksheet of a spreadsheet, and it'll come into this Pandas data structure. And this Pandas data structure allows me to have all the columns have headers. Each row could have a header. I can manipulate the columns. I can add columns. I can delete columns. I can move columns around. It's a really versatile thing if you're doing any type of basic data manipulation. And since we still do a lot of spreadsheet stuff, CSV stuff, pulling in an entire CSV into Pandas and then doing that manipulation becomes very, very easy to do. Excellent. So we talked a little bit about automation in general, and we've talked a little bit about robotic process automation, and we talked a little bit about Python. Now, so far, the first two examples were quite different in nature. So if we think about this for a second, the problem that robotic process automation is trying to solve is really that chair swivel. The problem that Python is trying to solve is more of those general use cases, data manipulation. Maybe I'm doing something like AI, like machine learning, using TensorFlow. Maybe I'm doing game designing, but something where it's a true programming language where I'm trying to think about things from a coding perspective and a logic perspective. Okay, and that's really the direction that I want us to take this, because that is a significant difference that we're going to see. The output of a robotic process automation exercise is really a script. It's a script telling the robotic process automation engine to do something for me. Python, the output is more of a traditional program. There's if-then statements, there's checks, there's function calls, there's all of the stuff that we're used to in a normal programming language. Ansible, on the other hand, is quite different. What Ansible is going to do is Ansible is what's referred to as a declarative language. And what I mean by that is this is going to tell us not what the logic is, it's really more of defining what I want versus how I want it done. So when you look at Python, it's much more focused on how. Ansible is focused on what. And so let me give you a simple example. If you have children, I have 4. If you have children, you might say to your child, clean your room. So that's really more of this declarative language. What you're wanting is you're wanting an end result where the room is clean. You're not really talking about how. I want you to pick your dirty clothes up and put them in the hamper. I want you to hang all your clean clothes up. I want you to take your toys and put them in the toy box. I want you to make your bed. That's more of the how. Also, you're not talking about order, right? You're not saying, 1, I want you to pick up all your toys, and then 2, I want you to throw the trash away, and 3, I want you to make your bed. You're just saying, I want the end result to be your bedroom is clean. Now, if your bedroom is already clean, great. Don't do anything. And if your kids are like mine, that's not true, but that's what Ansible is trying to say. Is it's trying to be this declarative language that's focused on what the outcome should be, not how to get to that outcome. And this is really important because a lot of times when we're thinking about how we're going to do automation, we think more process-oriented than we think outcome-oriented. And when we start to think things more outcome-oriented, that's really when we're starting to see some real power of this automation. All right, so that being said, let's look a little bit about how Ansible works. And I'll talk a little bit about what Ansible is as well. So Ansible is an automated, it's trying to solve automated, repeatable things. Maybe this is configuration management, application deployment upgrades, multi-vendor capabilities, and such. We're going to deploy something called an Ansible controller. And what the Ansible controller is going to do is it's going to interface with a large number of physical devices, or maybe it's going to interface with some virtual devices. So what I want you to think about is I want you to think about the fact that you're needing to manage a network. And for the sake of this discussion, let's say that that network is composed of 1,000 servers and 500 routers. We won't even worry about the virtual infrastructure at this point. So I need you to update all 1,000 of those servers from Ubuntu 16.04 to Ubuntu 18.04. How are you going to do it? Well, prior to tools like Ansible, what we would do is we would log on to each one of those 1,000 servers and we would update the software. Now with Ansible, what you're able to do is you're able to provide a list of nodes, and Ansible will do all that work for you. All you have to say is, I want my servers at Ubuntu 18.04. A little bit more complicated than that, but that's the general gist of it. Same with the routers. So what Ansible's trying to solve is it's trying to enable infrastructure automation. Deploy and manage applications, speed service delivery, streamline installations like things like OpenStack, and accelerate container adoption. Back in 2015, Ansible was acquired by Red Hat, so there's two versions of Ansible. There's an open source version of Ansible, and then there's a paid version of Ansible. Now, where the name comes from, I'm a big science fiction buff, and so the name I found very interesting. The name Ansible was a fictitious device that was created by an author by the name of Ursula Le Guin in a book that came out in 1966 called Rakonan's World. Now, and it's really a play on the word answerable, right? So they took the word answerable and they kind of shrunk it down, and that's where Ansible comes from. And the main premise of this is Rakonan is trying to get to this device, this Ansible device. And the way the Ansible device works is instantaneously, it can talk to any device in the universe. And so we don't have to worry about distance. We don't have to worry about speed of light. And so Rakonan is trying to have a conversation with somebody to tell them that someone is going to, it's really kind of funny, someone's going to attack the planet he's on in 8 years. They're going to arrive in 8 years. And so you need to leave now so you can be here in 8 years as well to stop them. And so I really like that concept. And it was kind of a fun book to read. All right. So a little bit of history of managing devices. So it used to be, if you go back, 15, 20 years ago, we used to treat all of the nodes that we're managing as snowflakes, individual, one of a kind. Then we moved to, and whenever we had any problem, we had to manually do something with that. Now what we're trying to do is to have things that are more generic that we can manage all at one time. And then there's a concept that people look at called moving from pets to more farm animals. And so if you think about it, if you had a server, you typically named your server. So you gave it a name. If it got sick, you took care of it. And you nursed it back to health, and everything was fine. So every server was unique. When back in this era, we used to have a set of servers, and we named them after trees. And so we had oak, and we had elm, and we had maple. And I remember oak was our email server at the time, and oak got some type of a problem, and our email server had issues, and so we nursed oak back to health. And then when oak was working properly again, we all were so excited because oak was fine. That's not what we want to do. What we want to do is we want to treat these things like farm animals. If one gets sick, you just get rid of it and get another one. And that's what we're trying to do with Ansible. And there's a concept called infrastructure as code. It's also sometimes referred to as code as infrastructure. And what this is trying to say is it's trying to say, I'm going to treat all of my servers the same. I want my servers to be indistinguishable from one another. So therefore, if a problem comes up, what I'm going to do is I'm going to solve that problem with some type of code. And if I can't, I'll just rebuild that server. I don't know if you've done this in the current virtual world. If I'm trying to deploy something, I'll use a virtual machine. I'll try to install it. If I get to a point where I've corrupted something, I delete the virtual machine and I start over. I don't nurse it back to health. I don't try to figure out what Python code or what program I installed that caused the problem. What I do is I just kill it and start over again. And that's really what we're trying to accomplish here. Now, the way Ansible works is it has a number of modules, and these modules, underneath those, what's built into the modules is really the how. So what we're trying to do within Ansible is we're declaring the what and letting Ansible figure out the how. So there's template functions, there's some cross Linux distributions, there's special functions. A lot of them are open source and they are extensible. And there's a list of them, and the list just goes on and on and on and on. It's a very long list. Ansible is, question, but what if we need to understand what went wrong and diagnose the root cause? It may pop up again and again, though, right. So you're asking a very good question. You're asking a very good question. And you're right. It depends on the nature of the problem you're trying to solve. And you've already heard me use that phrase a number of times. It depends on the nature of the problem you're trying to solve. So if what you're trying to do is you have a very specific system that's doing a certain thing, yes, you may need to diagnose what that root cause is. If you're doing development, you definitely have to diagnose what that root cause is. If what you're doing is you're doing a virtual machine that is providing some server for you, do you really need it? Do you really need to know what the root cause is? What you need to do is you need to potentially just rebuild it and start over. Or you have multiple copies of it and you just destroy the one that's not working and then you build another one. It really depends on the nature of the problem that you're trying to solve. Now, if you're dealing with an issue that's within the application, not within the infrastructure, then I agree a little bit more with you. But it really depends. It really depends. The goal, though, is to try to move towards a mentality where the infrastructure, the thing that we're trying to manage, is just one of many, not something special, not a snowflake. Now, just like what we talked a little bit about with RPA, you might not get there in the short term. You might have snowflakes that you have to manage. At Award Solutions, we do. We have some older systems that can't be treated in this generic, this infrastructure as code way. But the goal is to eliminate all the snowflakes, because the snowflakes are hard to manage. I hope that helps. One other thing that's very important is Ansible is idempotent. What this means is, if I tell it that I want to do the same operation over and over again, I'll get the same results. So let me go back to my example of clean your room. What I'm saying is, I want your room clean. Now, if your room is clean, don't do anything. I don't need you to clean something for the sake of cleaning it. I'm just telling you what I want, and then you're telling me that you've accomplished that. Let me give you another example. Let's say I've got this 1,000 servers that we talked about earlier. And of those 1,000 servers, I want to create a user for the sake of a specific vendor. And I want that user to be created on every one of those 1,000 servers. So what I can do is I can say, I want this user created on the 1,000 servers. Now, if the user is already there on 300 of it, great. It looks and says, hey, the user's there. Let's move on. It doesn't create another one. It doesn't create a variation of the name. It doesn't overwrite what's already there. What it does is it says, oh, that user's already created. Let's move on. So every time I ask it to run, the results will be the same. So I want the end result to be 1,000 users with this username. At the end of the day, all 1,000 servers have that username, no more, no less. We've talked a little bit about that it's a declarative language. And as we've already said, it's focused on the what's versus the how. Now, the how are these modules that we talked about. And every vendor of equipment, every vendor of software is writing, not everyone, but most of them are writing modules so that you can control their software. So for example, if I'm wanting to interface with a Red Hat server versus an Ubuntu server versus a Xero server, I would use the appropriate module. If I'm connecting to a Juniper router versus a Cisco router, they would have their own modules. Because every one of these things operates slightly different. So I have to use the right module for the thing that I'm trying to interface with. And if I use the wrong module, if I try to use an Ubuntu module to talk to a Cisco router, it gives me an error. It doesn't know how to communicate with it. I create groups. I can assign privileges. I can make users active. I can do all sorts of individual things depending on what's the what that I'm trying to do. I was working with a client not too long ago, and what they were doing with Ansible was it was simple, but it was super powerful. They were just trying to make sure before they launched their network that they were able to contact each of those servers. Every one of those servers had a NIC card configured properly, and that they had the right IP address. That's all they were doing. And so instead of logging on and manually doing that, they wrote this simple little script. Back to internal to Award Solutions. We have an OpenStack class. And what my colleague who runs our lab, what she used to do is she used to log on to some student VMs to make sure everything was right. She'd kind of spot check. And she left me in charge one day, which was scary enough on its own. But after she left me in charge, I thought, I don't want to spot check. I don't like spot checking. It makes me nervous. But I'm lazy. I don't want to log on to every student VM. So I created an Ansible program. And all the Ansible program did was it logged on to each of the VMs. It looked at the directories, and it made sure the directories that needed to be there were there. It took me probably half an hour to write this Ansible script, and then it took a minute to run. And at the end of that, I knew everything was set up properly. And so it gave me a lot of comfort. Now, the next time she left me in charge, I was able to use the same Ansible code. Didn't have to rewrite it. It was simple, worked right away. So that's the power of this declarative model. That's the power of this, of Ansible. So a simple example, within Ansible, they have something called a playbook. That's the name of the script. You'll create a playbook. That will go to the Ansible controller, and then it will do whatever you need it to do. In this example, deploying an operating system, deploying a virtualization layer, and maybe providing some upgrades. Now, one of the other things that's very valuable about Ansible is it falls into the DevOps mentality. And DevOps is a very, very popular term right now. And what DevOps is all about is having, allowing innovation and change from the development side, stability from the operation side come together, and we can have frequent incremental changes with automated testing for stability. This gives us business process agility. This gives us the ability to update tools very fast. But some of the challenges, a lot of times, is the development environment and the live environment are different. Development tools and operational tools are different. And that's where something like Ansible can come in and help bridge that gap. So now what we can do is we can have the same environment. We can do testing on one server, and then we can roll it out to all of the other servers. And I've seen some examples of that work very, very well, where we write a playbook in Ansible, we test it on one server, and then we test it on maybe 10% of the servers, and then we send it and we roll it out to everything within our system. Fantastic. And that's a little bit on Ansible. Let me open things up for questions and answers at this point. If you have any questions about any of the stuff we talked about, if you have questions on really anything in this automation space, I would love to hear those, or any thoughts that you have. Well, if you do, go ahead and add some in the chat if you do have a question. I just want to wrap things up for anybody who needs to go on to the rest of their day. Again, just a reminder, the data automation workshop with Python, where we'll be focusing on looking at some very specific use cases within Python. We'll look at some of the key libraries that are there, and then we have a discount code associated with that. If you have more questions about anything within Award Solutions, feel free to reach out to me. You can find me on LinkedIn, or you can go and send an email to info@awardsolutions.com. Just as a point of reminder, give us a few days and you should have an email that has the ability to download the presentation as well as view the webinar. Thank you guys so much for your time today. I really appreciate it. We'll be doing another webinar in September focusing on artificial intelligence, and I hope to see you then. Thank you so much and take care.